All right, guys. So to start out this week, we are actually going to finish up the last new thing in unit number 6, which I wanted to finish. We would have finished easily before our time before the end of third term, even with a midterm. But so it just puts us one day behind where I wanted to be. Anyway, today our goal is to use the normal distribution to approximate binomial probabilities. All right, so we do use the binomial formula in chapter 6, but if we have large data sets, it takes too long. So we use the normal distribution. Now remember, the normal distribution is continuous. Okay, a binomial distribution may not, the binomial formula may not be necessarily continuous. So what we need to do is we need to make a correction. Make a correction for continuity. And guys, the correction is always 0.5. So for example, if I want exactly um, 50 heads, what I would use would be the range from 49.5 to 50.5. If I wanted exactly 52 heads, and the key word here is exactly or equal to, then I would do a range of 51.5 to 52.5. Notice there's 0.5 on either side of the exact number that I want. Now it gets a little bit trickier when I want to do, for example, over. So if I want over 60 heads, my continuity correction is to use 60.5. We don't want to use 60 exactly because we may be a little bit off. So we're going to use the 0.5 over 60. And then if I want at least 60, I'm going to use 59.5. Okay. Now I know this seems weird. This is what it kind of looks like when we're doing our picture, which I keep telling you to do, and I wish I could see if you were doing them. Some of you I know are, because I saw it on your test. So let's say that we wanted exactly 50. So here's our 50. Our continuity correction shows up this way: 49.5 to 50.5. Okay. Hopefully that makes sense. And I think this makes a little bit more sense if we actually do a problem. So I'm going to do one long problem, and we're going to do a couple things with it, and then tomorrow you'll get your homework. It seems that my dog is going to start barking soon. It seems 16% of the stat students think they can do well in this class without doing homework. So for a class this size, that means one of you. Okay. But let's say that I have 60 students. in stats. Find the probability that less than 6 students feel this way. Okay, well let's start with that one. First, again, remember we need to use the binomial, but again, we are going to do what? We are going to draw our picture. Okay, so here's our picture. What do you notice that we don't have? There's nothing about here that gave us a mean, is there? But there is a very easy way to find the mean. Do you remember? Mu is just simply n times p, where n is the number of students and p is the probability. Well, in this case, n is 60, because there's 60 students, and the probability of students feeling this way is 16%, so 60 times 0.16. So our mu is going to be 9.6. So on our picture, we draw 9.6. Okay, well, how do I find standard deviation? Hopefully you remember that that is just sigma is equal to the square root of n times p times q, or the square root of 9.6, that's my n times p, times 0.84. Remember, q is just 1 minus p. So if I find that, I find out that the standard deviation is 2.839. Great. So now what do we do? Well, we were looking for 6, okay? And what did it say? It says less than 6. So we don't want to go all the way up to 6, so our continuity correction is actually at 5.5. And we want to shade into the left. Okay? So now it just comes back to our z-scores. So z equals observed. It's not 6 now, it's what? 5.5 minus 9.6 over the standard deviation, which happens to be 2.839, which gives us a z-score of negative 1.44 and a probability from our blue chart of 0.0749 or 7.49%. And again, we shaded to the left. Remember that this number is to the left, so that is our answer for that. Okay, so basically you have to go back to the binomial formula, which I know you all found easy, and you have to make a continuity correction. All right, and that's all that we're doing in this section. It's actually pretty straightforward. Now, for part B of this question, it's the same question. I want to do from 6 to 8 inclusive. And remember, guys, if you get stuck, or if you're not quite sure what I'm talking about, just go back, watch the video again, or stop the video. It's not a problem, okay? There are no interactions on this one today, so you know, just play straightforward, and once you watched it, then you're done. All right, so let's see what our picture is. Now, what's nice is our mean and our standard deviation don't change, which is always good. So what was the mean again? I hear you, it's 9.6, okay? And what am I looking for? I'm looking from 6 to 8, but I want to be inclusive. That means I want everything from 6 to 8, so I'm going to do my correction from 5.5 all the way up to 8.5. That way I'm sure that I have included everything in between. Okay, the hardest thing is to figure out which way to put the 0.5. Once you've got that, everything's easy. Well, you already know the z-score for 5.5. Z of 5.5 was equal to negative 1.44. So you need to find the z of 8.5. Well, that's just simply 8.5 minus 9.6 over the standard deviation, which also didn't change, of 2.839. So that z-score is actually negative 0.39. Now this probability doesn't change. Okay, so what is that probability again? 0.0749. And if you use your blue chart for negative 0.39, you get 0.3483. And again, what do I want? I want the area in between, so I have to subtract these two. So 0.3483 minus 0.0749 gives me a probability of 27.34%, or 0.2734. I'm hoping that makes sense because it seems pretty straightforward. Now part C. Over 8 students. Again, draw your picture. Does the mean change? No. So once you find the mean, you don't have to, in problems like this, you don't have to do it again. Now here's my 8. Now what do you think? Am I going to do 7.5 or am I going to do 8.5? Well, if I want over 8, then I don't want to include 8, okay? But I want more than, so I am going to do 8.5 as my correction. So this is 8.5. Well, guys, we've already figured out the z-score for 8.5, z of 8.5. And remember, we're shading to the what? To the right this time. That's going to mean something different at the end, isn't it? You all know. So z of 8.5 is still going to be negative 0.39, and the probability is still going to be 0.3483. However, that's to the left of 8.5. What do I want? I want to the right of 8.5. So it's just a simple matter of taking the entire thing, 1 minus 0.3483, and ending up with 0.6517, or a 65.17% chance of over 8 students in this class of 60 feeling like they can get away without doing their homework. All right, look over this video again. Take your time. Please read through section 6.4 in your book. It gives you more examples. And then tomorrow morning, look for your homework. Thanks, guys. Have a great night.